Okay, so eventually when you're thinking of antiderivatives, you'll start to think in terms of some antiderivative formulas. Okay, and so here are some of formulas from what we've learned so far that you should be able to determine yourself at this point. So if I want all the antiderivatives of x to the power n, this is what I started to describe in example 69. Basically, you want a function that if I take its derivative gives me x to the power n, well then I'd add 1 to the power, n plus 1, and divide by that n plus 1, right? Because if I take its derivative here, I get n plus 1 times x to the n plus 1 minus 1. So the n plus 1's cancel, and I have x to the n left. So that's like a formula for x to any power. And then, of course, always add your plus c. It doesn't work if n is minus 1, of course, because I'm dividing by 0 then. So if n is minus 1, it's actually a special function, and we're not going to talk about that in Calc 1. Okay, and then you have the derivatives. We want antiderivatives for the trig functions. Well, you have to think about, well, what are the derivatives? So the derivative of cosine of kx is minus sine of kx times k. So I need to put a minus sign in front, so the minus signs cancel, and then divide by that k. So then I just end up with sine of kx. And all of these trig functions work that way. Okay? Derivative of cotangent is minus cosecant squared, so I have to have a minus over here, and then I got to divide by that k that's in here, so I just end up with cosecant squared x once I take its derivative. So that's how you can think of these as antiderivatives formulas. There are actually books of tables of these formulas, and they're called the CRC tables, but we're just going to talk about a few here in Calc 1, these guys.